Okay, so we're going to start talking about exercise 1.5, and exercise 1.5 is doing three-point perspective. So this is an example that you have in the book. We have the horizon line up top, we have our shape, and you notice how the bottom of the cube is really narrow and then the top is wider. So it gives us the illusion that this bottom part is going away from us. And then since it also has 2 points of two vanishing points on the horizon line, we see that the left side is kind of smaller as it goes back into space. So we have distortion happening on the left side of the cube, the right side of the cube, and then also on the bottom as it goes back into space. So the third vanishing point is down here in our example. So we're going to go ahead and do a three-point perspective drawing. So we're going to start everything out like we did before. We have our horizon line, and then we have our vanishing point here and the vanishing point there. And for this one, we'll go ahead and start the box directly over the horizon line. So I'm going to do a line straight down here, put a little dot on the bottom and a dot on the top. And then we're going to create another vanishing point way up here. This is going to be our third vanishing point. So we do this the same way we started with our 2 point. This goes to the right. This goes to the left. And then at this point on the bottom, we got to figure out how wide we want the bottom to be. So I'm going to say it's going to go back this far on the right side. And it's going to go back this far on the left side. This edge right here just continues all the way up to that third vanishing point. But then we put this, we grab this point and we also take it to that third vanishing point. And then we take this point, take it to that third one up there. Now here at this point, we've already decided that this is going to be where our box ends. So from this point, we go down to the left vanishing point, and we go down to the right for the right vanishing point. And so now we have our shape. This is the right side, the left side. Since it's on that horizon line, we really can't see the top or the bottom of it. But we notice that this dimension is narrower and this is wider because we're closer here. If this were let's say a super tall building and it ended all the way up there, then it would look something more like this. We just take that point to the left vanishing point, to the right vanishing point, and now we're like looking up. This is more like a worm's eye view. Maybe this is a super tall, large building. We're at the bottom, we're looking up, and it's so tall that the top of the building looks narrower as it goes and distorts into perspective. And we're standing on the corner so we can see the left side of the building and the right side of the building at the same time. So this is a three-point perspective. Let's do another one more like the example that we have in the book. Okay, so we're going to start off the same. We're going to do a horizon line, vanishing point, vanishing point. We're going to put a third vanishing point down here. And then we're going to make our box below the horizon line. So I'm going to go and put a dot here and a dot there. Again, when you're doing this, do it super light so that you can erase out your construction marks. All right, so this goes to the left. This goes to the right. And we have to figure out that top. I'm going to say the top of the box ends at this point on the right side, ends at this point on the left side. We take this down to that third vanishing point, take this down to the third vanishing point. This one just kind of automatically continues to the third. We have this bottom point where the box ends. So this we go towards that vanishing point. And we do the same thing over here. We go towards that left vanishing point. And now we have to describe the top of the box since it's below the horizon line. So I'm going to grab this point. I'm going to go to the right. So I can hit that there. Rotate my paper so it makes it a little easier. I'm going to go over here. And so now we've got that top section, and then we have our right side and left side. And since it's below the horizon line, we can see the top. Now, if we take the same drawing and construct it the other way, just rotate it all the way 180 degrees, now we have the box above the horizon line, and now the top now becomes the bottom, and you can see the left side and the right side. So it depends on how you construct your cube, whether it's above, on, or below the horizon line. That's going to change the way the object looks. Let's just do one more really quick. I'm going to do this one really high. point, point. And since this one had the vanishing point below, let's do the vanishing point really high up here. Okay, vanishing point, vanishing point. Let's go left, right. Where does that box end? Take this up to the vanishing point, vanishing point, vanishing, oops, and vanishing point here. It's kind of fast. This point here, down to that vanishing point, down to this vanishing point. This point goes to the left. This point goes to the right. And now we have our box. And it gets wider at the bottom. It's narrower at the top. Our third vanishing point is up there. Our horizon line is down here. And since it's so high up, we can see the bottom. So this becomes the bottom plane. So that's exercise 1.5 in your textbook. The next section is going to be dividing a square. So here we have a square, and this example shows you how to take a square and make it into smaller sections. So we can take one square and break it up into fourths, and then eighths, and then sixteenths, and 32nds. So we're going to practice doing this operation from scratch. So let's take this off to the side, and let's draw right here. So the first thing I'm going to do is draw square. Now to find the center of the square, I'm just going to go corner to corner. And wherever those two orthogonals intersect, that's going to be the center of my object. So now I take a line that goes straight up and down, and I've broken this into halves. And then I can go horizontally across, and now it's into quarters. 1, 2, 3, 4 quarters. Now I can take any section. I'm going to take this bottom right-hand section, and I'm going to continue this operation. I'm going to go corner to corner, vertical, and then horizontal. So now I've taken this box and I've broken it into 4 smaller pieces. Let me go ahead and do this again, and now I have 4 smaller pieces. So this operation allows us to find the center of certain shapes and objects, and then also allows us to break that into smaller units that are in proportion. So for this particular assignment, on page 1.7, you'll see that it has certain cubes, and it's going to have you break these cubes up into specific shapes. So here on the left, we see this cube that's broken up in halves. So we have this left side and the right side, and they've done that by basically cutting this left plane open and finding the center, and then extruding the smaller rectangle off of that square. So this one, we'll talk about this one for a second. So we have draw a cube that's 5 by 5 by 10 inches. So let's see if we can start that out on this sheet. Okay, so we're going to start out with a cube that's 10 by 10 by 10 inches. Make this a little bit bigger so we can see what's going on. And it goes off to the left, off to the right, left, straight up, back, back. Okay, so there's my cube. I can determine what's going to be what dimension. So I can look at the height. Right now this height is 10, whether it's 10 inches or 10 feet or 10 meters. Since this is a perfect cube, or we're assuming it's a perfect cube, that this dimension is going to be 10. And then this dimension here will also be 10. And then this dimension going back over here is going to be 10. So you can think about, since it's a perfect cube, you can think about it in terms of length times width times height, right? And you can plug in any of these numbers for the length, width, and height. Currently it's 10, 10, and 10. But we want to make it 5, 5, and 10. So we need to break this cube up into smaller shapes, and then basically carve out a shape that is 5 by 5 by 10. So let's start off with this left plane over here. So I'm going to go corner to corner, find that center point. I'm going to do a vertical line. Now I've broken this up into 2. So if I wanted to look at this dimension, from here to here is 5, let's say, inches, and from here to here is 5 inches. If I combine both of those, I have 10 inches. And if I go up to this point, I can continue carving back into this other dimension. Now I've basically taken this cube and carved it in half. So I have 2 halves that are put together to make one whole. So I could potentially make this into 5. I'm going to keep this one 10, but when I go up in this direction, I want that, instead of to be 10, I want that to be 5. Okay, so I already have a center point here. I can take this back to that vanishing point and continue it all the way over here. I could also double check and make sure it's on the center. I can put my little center point here and take this back into this dimension. So I have an imaginary vanishing point that's over here somewhere. So now I'm going to find that center point and take it to that imaginary vanishing point, and then take this over to the left. Now, if I go in here, I can basically carve out a smaller shape from this larger shape. And let me switch to markers so you can see this a little bit better. So I have this top plane, and I have this dimension. This goes back, and that goes back. Okay, so let's start measuring this out. So from here to here, I have 5. From here to here, I have 5. And then from here to here, it stays 10. So by taking a cube that we're saying is 10 by 10 by 10 units, we can carve into it to create a cube that is 5 by 5 by 10. It's 5 in this direction, half there, and then 10 in that direction. So that's one way to carve into a whole cube to make a smaller unit.